exponential rules, a to the m times a to the n is what? M plus n. Okay. So I like that many of you were able to recite this, but can somebody explain to me why this is true? By example. Okay, so let's say a squared times a cubed. Why is this same as a to the fifth power? Not using this rule. Can you explain why this is?
You're multiplying the exponents, so you add them.
Yeah, you're just restating this formula in a different way. Okay?
You add the exponents.
Yeah, again, you're just doing exactly this, okay? Yeah. But can somebody explain why does this rule hold?
Because the bases are the same.
Huh?
The bases are the same.
No, that's just you're just saying what conditions are needed in order to use this formula. Yeah. Okay. All right. Let me try to explain this, okay? Yeah. All right. What does a squared mean? A times a. Right? A multiplied by itself twice. What does a cubed mean? A times a times a. Now, how many times did you multiply a?
5.
That's why. Okay? That's the answer I wanted. Okay? You guys, all of you are just using this rule. Okay? You were just reciting this rule in some different way, and you didn't really explain to me why that's true. Here, I've used the definition of what a square is, what a cubed is, and this would be true even to the person who doesn't know this rule. So, for example, somebody didn't know this rule, and you had to explain it. What do? You just say, oh, this is the rule. You just memorize it? No, that's not how you do it. You just say, oh, look at this example. A squared times a cubed. A squared is you multiply a twice, and you multiply a 3 times. And look, how many times did you multiply a? 5 times. And look what happened. Because you multiply a twice and you multiply a 3 times, overall it's 5 times multiplied. So that's a to the fifth part. That's why this rule is true. Good? All right. Since that one didn't go that well, let's see if this one goes well. A squared to the cubed. Oh, well, a to the m to the nth power is a to the mn. Very good. Okay, why does this work? So again, an example. A squared to the cubed.
Because you're cubing.
I know this is a to the 6. Don't try to tell me that, okay? Tell me why this is a to the 6 without using this rule. Yeah.
Because it's a squared times a squared times a squared.
This is a squared times a squared times a squared. And a squares are a times a, right? A times a times a times a. And remember how you learned multiplication for the first time? You have a bag of candies, 3 bags of candies, and each bag has 2 candies in there. How many candies do you have in total? You do 2 times 3. That's how you get a to the 6th. Isn't that how you get it, right? So this is a to the 6th because of what I just said. Okay, you have 3 bags of candies, 2 of each, and 2 times 3 is 6. Okay, that's why these 2 get multiplied. Got it? Okay. Now let's try to do another rule. A to the m divided by a to the n is a to the m minus n. Okay. Why is this true? Well, again, a to the 5th power divided by a to the 2nd power is a to the 3rd power. Why is this true? Without using this rule. Yeah, can you explain?
5 A's over 2 A's. And
Right, so the top is you multiply a 5 times, and you divide by a twice, and you can cancel these, and you end up with a times a, which is 3. So, in other words, if you write out how many a's you have m of them, and if you write down how many a's you have down here, you have n of them, and then you start canceling, what you're left with is m minus n. Right? So these are like the very basic rules, but now we have some extension of these. You have some extension of these, and the first of it is, what is a to the 0th power?
1.
Okay. Well, a priori, it doesn't have a definition. A to the 0th power doesn't have a definition because, when you have a to some positive number, whatever that is, like 7 means a times 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 a. That's what it means. We know the meaning. But what do you mean you have a and you're multiplying by itself 0 times? It doesn't have any meaning at all, right? So it doesn't make sense. However, let's say you really wanted to define a to the 0th power. Okay? Then you want to make it such that it still satisfies these definitions. Agreed? Right? I mean, you don't want to have a new definition for a to the 0 and suddenly for that new definition these don't work anymore because these are nice to have. Okay? So the way we are going to define a to 0 is to see if there's any way to get 0 from here. And we see that in here, if we have something like a squared over a squared, according to this formula, what's that?
1.
2 minus 2. 2 minus 2. So a to the what power? 0th power, right? And on the other hand, what's a squared divided by a squared? Anything divided by itself is? 1. So what's our conclusion? A to the 0th power must be 1. Now, if you don't have a to the 0th power as 1, if you put some of you suggested a to the 0 should be 0. If you do that, it no longer supports this formula and it's bad. Okay? So that's why a to the 0th power should be 1. Agreed?
Agreed.
Okay. Now, what about a to the negative n power? What's that equal to?
1 over.
1 over a to the nth power. But again, this doesn't have any meaning. What do you mean by a to the negative 2? Doesn't make sense. How can you multiply a negative 2 times, right?
Can't.
You can't. However, look at this. If I just plug in 0 for m here, what do you get? a to the 0th power over a to the n is a to the 0 minus n. Isn't that right?
Right.
What's a to the 0?
1.
You agree that it's 1, right? And 0 minus n is negative n. So that's how you get this. Okay, this formula implies that this is true. All right. Okay. The next one is the following: square root of a is same as a to what power? Square root of a is same as a to what power? Okay, let's just say n that we don't know. So it's just some number n that I don't know. Now, however, if I square both sides, what's the left side? Square root and square cancels, right? So you get a. What's the right side according to this rule? 2n, you have to multiply. If you have two exponents like this, they multiply, right? So it's a to the 2n. Now, a by itself is a to what power?
The first one.
First power. So if a to the first power is equal to a to the 2n, what is n?
1.
If 1 is same as 2n, what's n?
2. 1 half.
1 half. 1 half times 2 is 1, right?
Mm.
Okay? So going back, here's what we just found out. We found out that square root of a is same as a to the 1 half power. Okay? Square root of a is same as a to the 1 half power. Now we can play the same game for nth root of a. If you have nth root of a, and you write this a as a to some power, x is the unknown thing that we want to figure out. Now what do you get if you take nth power of nth root? What's nth power of nth root? So if this was a cube root and you take the cube, what do you get? They cancel, right? So they cancel, so you get a equals to a times x times n, and a by itself is a to the first power, so you have 1 equals to x times n. And the goal is to find x. How do you isolate x? How do you
Move n over,
isolate?
Move n over.
Divide both sides by n. So this is canceled, so x is 1 over n. So what you get at the end of the day is square root of a is 8 to the 1/2 power, and if you have any nth root of a, that same is a to the 1 over n power. Okay, so these rules, although you may have learned it like if this was just thrown at you, these are quite natural.